students, today we will be starting a new session for plus 1 chemistry students, and I'm going to start with the lesson chapter 2, structure of atom, and the topic I'm going to discuss is discovery of subatomic particles. As you know, the atom contains the subatomic particles, protons, neutrons and electrons. So today I'm going to discuss the discovery of electron done by J.J. Thomson. And as you know, electron was discovered by J.J. Thomson by using cathode ray tube experiment. Cathode ray tube experiment. Okay. So when you look at this diagram, you can see a cathode ray tube. This is also called a discharge tube. Okay. Discharge tube, otherwise known as Crookes tube. It's like a cylindrical glass tube. Look at the diagram. It's like a cylindrical glass tube about 50 centimeter long, and it is closed at both ends. The ends are closed, okay, and it is fitted with the two electrodes. One is cathode and the other one is anode. And cathode will have negative charge and anode will have positive charge. Okay, and these are connected to a source of high voltage. Now the tube is also connected to a side tube where a vacuum pump is connected, okay, so that the gas can be evacuated. The gas can be pumped out so that we can decrease the pressure inside the tube. Okay, so this is the basic arrangement of the discharge tube. Now, so in order to conduct an experiment, we have to fill a gas, okay, for studying the nature. So any gas we can fill over here, okay, and if we fill any gas at a normal pressure, okay, if you fill any gas at normal pressure, nothing is observed even by applying a high voltage, which means that the gas is non-conducting. It is not conducting electricity. This is happening at a normal pressure. Okay. Now, the pressure of the gas you need to decrease by pumping out it with the help of the vacuum pump. Okay. And when the pressure of the gas is decreased to 1 millimeter to 10 millimeters of mercury, the gas becomes conducting and light is emitted in the tube. So this is happening when the pressure is decreased, okay, when the gas is pumped out by using the vacuum pump, so that the pressure is decreased to 1 millimeter to 10 millimeters of mercury, so that the gas becomes conducting and the light is emitted in the tube. When the pressure is further reduced to 0.01 millimeters of mercury, the glow of the light is stopped, but the gas continues to conduct electricity. When we reduce the pressure again to 0.01 millimeters of mercury, the glow of the light will be stopped, but the gas continues to conduct electricity. Okay. The glass tube at the anode begins to glow with a faint greenish light. So when we decrease the pressure to 0.01 millimeters of mercury, what will happen? The gas will be continuing conducting electricity, but by the time the anode side, this is the anode begins to glow. And what's the color of the light? The light is greenish light, you can see. Okay. So the scientist has discovered that some rays are emitted from the cathode and move towards the anode in the form of light. Okay. With the 0.01 millimeters of mercury, it is discovered that some lights are emitted from the cathode and it is moved towards the anode. That's why we can see a faint greenish light on the anode side. Okay. But that is still invisible. The light rays are invisible. We cannot see anything, but we can only see some greenish light on the anode side. So further to study, the scientist has made a hole in the anode. Okay, look at the second diagram. A hole was made on the anode side. Okay, and a fluorescent material. This is a fluorescent material. A fluorescent material was coated on the anode side, back of the anode side. Okay, so when the light rays are passing from the cathode, okay, and when it strikes on this anode, okay, a bright spot is observed, or a bright spot is developed on the back of the anode on the fluorescent coating. Okay, fluorescent coating, like there are different types of fluorescent material. Here it is used with zinc sulfide. So when some invisible lights strikes on the fluorescent coating, okay, there will be a bright spot will be developed. And this is the rays are originating from the cathode. The rays were called cathode rays or cathode ray particles. So what is cathode rays? Cathode rays means the rays which is originating from the cathode. That's why it is called a cathode rays, or we can say cathode ray particles. So this is a basic experiment conducted by J.J. Thomson to discover the electron. These cathode rays are negatively charged particles because it's starting from the cathode. So it is having negatively charged particles, and we nowadays we call it as electrons. Now, what are the properties of these cathode rays? Cathode rays starting from cathode, okay, and move towards anode. So now we are going to discuss the properties. The first property, you can say that it is starting from the cathode because it is having a negative charge, okay, and it is moved towards the anode. So whenever an object is placed inside the tube, it produces shadow on the wall, which means that cathode rays travel in straight line. This is actually a property of light. When we place an object in front of light, you already know a shadow will be formed. Okay, because light is obstructed or light is hindered by the object, so that a shadow will be forming. That's called a rectilinear propagation of light, which means that light can travel in a straight line. So the same property can be observed in cathode rays also. So if we place any object inside the tube, okay, there will be a shadow formed, which means that cathode ray travels in straight line. Now, so that is the first property. Second property, these are invisible rays. We cannot see with our eyes, but it can be observed. These rays can be observed with the help of fluorescent material, so which glow when it hit by them. Okay. Now, cathode rays produce mechanical effect, which means that if you place a small paddle wheel here, if you place a paddle wheel here, cathode rays when hit on the paddle wheel, it can rotate. It will be rotating, which means that cathode rays can produce mechanical effect. Then, in the absence of electrical and magnetic fields, these rays travel in straight lines. If we are not applying any electric field or magnetic field, these rays travel in straight lines. But what will happen if you apply an electric field? When you apply an electric field, okay, of two electric plates with opposite charges, these cathode rays are deflected towards the positively charged plate. Okay, so if you are applied a negative charge and a positive charged plate, okay, on the cathode rays, so these rays are deflected towards the positively charged plate, which means that cathode rays carry negative charge. So we call these negatively charged particles as electrons. Okay, now these properties of cathode rays do not depend on the nature of electrode and the nature of the gas in the discharge tube. So while conducting this experiment, okay, we are using some kind of metal electrodes. If you change the metal electrode with another metal, okay, still the properties of the cathode rays remain same. Even if we are changing the gas also, the properties will not change. Which means that the properties of the cathode rays will not affected by the nature of electrode and the nature of the gas in the discharge tube. This means that electrons are the basic constituent of all the atoms. Okay, and then the sixth property is that cathode rays produce a heating effect. If you place a metal foil in front of the cathode rays, it will be heated up, which means that the cathode rays producing heating effect. Then cathode rays produce X-rays when strike against hard metals like tungsten or copper, etc. Okay. Now the last property is that cathode rays can penetrate through the thin sheets of aluminum or other metals. So these are the 8 properties of cathode rays. Okay, children. Today we discussed the discovery of cathode ray tube experiment. Okay, which lays the foundation of discovery of electrons. Okay, an electron was discovered by J.J. Thomson, and the experiment we call it as cathode ray tube experiment or discharge tube experiment. I think you understood all the concepts well. Thank you, children.